Hey friends, so welcome to my final project of ENPM 808X. It's called Marauders Map, which is basically mapping an unknown environment using RGBD SLAM and an exploratory behavior with Turtlebot. And this is me, Karan Bhargav. I'll be going over all the basics of how I created the map and about myself. I am basically a master's in robotics student at University of Maryland, and I'm working as a research scientist in Fraunhofer. Currently, I'm working on a quad rotor based mapping for nursery plants, and my interests lie in computer vision, deep learning, NLP, and their applications in robotics. So, a little bit of overview of what was used in the project. So, I used ROS Kinetic and the Turtlebot platform, and what I created was an exploratory behavior to map the environment and integrated the RGBD SLAM into the exploratory behavior so as to get a full map of the environment. And the final output was an octree file which was used with RGBD SLAM's services. So the application of this would be to create a map for hazardous environments. Many a times, as humans, we are not able to venture out into hazardous environments, so robots can do this work for us. And this can also be used for search and rescue missions, as well as it's important for localization purposes. So let me just tell you about what challenges I faced. So the major challenges in this project were the selection of the SLAM algorithms, and the most important thing that I would say would be to make them run on the system, because most of them are really good packages, they work really well, but installing them is a real pain. So I surveyed the following ROS packages, which are OBSLAM2, RGBD SLAM, which is version 2, and SVO. SVO is really fast. OrbSlam has decent results, but RGBD Slam I found the best amongst these three, so I used that. So how does it work? Here I am working with the laser data to create an exploratory package. So as you can see right here, we have an exploratory package. We have the laser scan data coming in, and I'm trying to find the minimum distance of the robot to the obstacle, and I'm publishing it on a min distance topic. Now I'm checking whether the min distance is less than some threshold. If it is, then I'm setting a collision flag, and this is being used by the path planner node to check whether it should turn clockwise or keep moving forward. So this keeps happening until the node is killed, and once we're satisfied with the mapping, we kill the node. This is the class diagram for the same, and the path planner is dependent on the obstacle detector, since we are using it right here. Alright, so the dependencies, the RGBD SLAM will be used to get the map for the environment, and the easiest way to install it would be to run the script in the repository that I've given. I've modified the script a little bit, and as well as the RGBD SLAM code, so as to kink out the bugs which were already existing in the code. I believe now it should run fairly smoothly, and you should be able to install it. And if not, you can use the RGBD SLAM, which is the one given in the official website, which I've included in the documentation. Now, how to build this? We will follow these instructions in a video